there, welcome to this video. Today we're going to talk about rate in, rate out applications involving integrations. This is one of the core common FRQ questions on the AP Calculus exam. So you're going to want to watch this video and learn how we deal with questions that ask about a rate coming in and a rate coming out. Usually these are one of the first two FRQs on the exam involving a calculator active free response. So we're going to go ahead and talk through those. All right, so let's go ahead and look at an example from 2017. This is question number 2 involving the minions' favorite, the bananas. So when a certain grocery store opens, it has 50 pounds of bananas on the display table. This is very important because these problems often give you an initial value. So right there's your initial value. Customers remove bananas from the display table at a rate modeled by f of t. So this is very important. They're giving us customers remove bananas at a rate of f of t. Okay? Where f of t is measured in pounds per hour, and t is the number of hours after the store has opened. All right. Now, after the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by g of t because there are so many minions coming in and taking all of the bananas that they have to add more bananas. Oh, I'm just kidding. That wasn't part of it. I just added that. We have g of t. This is employees adding bananas to the display table at a rate modeled by g of t, where g of t is pounds per hour, and t is the number of hours after the store has opened. Okay, a couple of things. They gave us an initial value. They gave us a rate out. So I always like to say this. Okay, this is out, and here is the rate going in. We're adding bananas. Okay, so what we're gonna have to do, it's very, very smart first to just identify these. The rate in, like we talked about, this was g of t, and this was in pounds per hour. Units can help us big time in these questions. Okay, it's going in to the amount. The initial amount at time 0, sometimes that changes, but usually it's 0. We had 50 pounds of bananas on the display table. So there's your initial amount, and then our rate out, this was f of t. Okay, and our units again are pounds per hour. So what you want to do in these questions is you want to make an equation for a of t, the amount of whatever you're talking about. And in this case, this is the amount of bananas on the display table, on display. Okay, and usually this will be in pounds, if I can spell pounds, pounds. I don't know why I'm so bugged out about that. Okay, so a of t. What is our equation for a of t? Well, I'm starting with 50. There's 50 pounds I'm starting with. And then minions come into the store, and at time 0 and up until a given time t, whatever time t, okay, we're taking these away. So this is going to be f of x dx. And the variables change. You want your variables to be different here in this, because when we end up plugging in t, it can't be the same variable. So okay, there it is, and I'm going to add. We eventually add bananas up until starting at 3 hours after the store's opened up until hour t, whatever time we want to find this at, assuming this is after 3 hours. Pardon me. And this is of g of x dx. Again, I want different variables from what my independent variable is. So right up here, my upper limits should match my independent input. Okay, so they'll generally ask you a question about this involving the a of t, the amount, where you have to integrate these values. And then 2, they'll ask you for an equation for a prime of t, usually comparing to see if something is increasing or decreasing. So if I were to go ahead and take a derivative of this, derivative of 50 is 0. The negative derivative of negative integral from 0 to t f of x dx. This is just second fundamental theorem of calculus. Negative f of t, okay, plus g of t, okay? And we can rewrite this. This is always g of t minus f of t, right? The rate of bananas being added, well, you're just going to take the amount being added, subtract the amount being removed, and there you have it. Very intuitive there. Okay, anyway, let's go ahead and see how these questions are asked in this FRQ and how these functions can help us. So A, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? Okay, notice they say how many pounds of bananas. So I don't want pounds per hour, okay? So this helps us identify that we're going to integrate the amount being removed, okay? And that is f of t dt. So I want to find this amount. How many bananas are being removed? Now notice I don't use my initial amount too because they're only asking about how many bananas are being removed. So this is a calculator question. Never compute an integral or a derivative on a calculator FRQ. Have your calculator do that for you. So I'm going to open up my calculator. I'm going to go to a new document, add a calculator, and the first thing I'm going to do on these is you want to go ahead and define. So menu, actions, define, and what we're going to do here is define our function. So f of t is equal to 10 plus 0.8 t times sine of t cubed divided by 100. Okay, looks good. All right, if I'm going too fast, pause me so you can enter this. And then what I'm also going to do is I'm going to do the same. I'm going to go ahead and I'm going to define g of t. So g of t is equal to 3 plus 2.4 natural log of t squared plus 2t. Okay, done. There we go. Sometimes too, it's a good idea to go ahead and identify a of t. A of t. What the heck is a of t? Well, a of t is going to be equal to what we said, 50 plus the integral from 0, actually minus 0 to t of f of x dx. And notice how that f of x is bold. It already recognizes, hey, we've already defined that, plus the integral from 3 to t g of x. This is bananas being added. Hit equals, and did it give me a done? Should say done. Why are we not saying done? Ah, I know. I didn't define it. That was my issue. So let me re-enter this and type define. And there we go. Okay, now it says done. All right, so I have went ahead and I defined and showed you what not to do. Defined my two functions and then defined the function involving all of them. Okay, so I want the integral. So I want the integral from 0 to 2 of how many are being removed? That's f of x. F of x dx. Okay. So there we go, 20.051. So this is 20.051. Okay, and note that this is in pounds. You could respond in a sentence, but they didn't ask for units. They didn't ask you to interpret. There is your total amount being removed. Okay, next part, part B. It says find f prime of 7. There's task 1. Find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. Okay, so again, for units for f of x, these were pounds per hour. That's the initial amount given. So if I want the derivative of that, that's going to be pounds per hour squared. So that's something to keep in mind here, okay? And I'm going to say, okay, what is f prime of 7? We're going to go to our calculator, and we're going to take a derivative at a point. Okay, I want the derivative at 7. I'm going to say, okay, what's the derivative of f of x dx at 7? And that's negative 8.120. I'll round, negative 8.120. Okay, and let's interpret this in context. What does this mean in context? So f of x, that's the bananas being removed. So the, and it's the rate the bananas are being removed. So the rate bananas are being removed from display is, and what is it, increasing or decreasing? Well, it's negative, so this is decreasing at a rate of 8.120, and we want our units pounds per hour squared. Pounds per hour squared at time t equals 7 hours, or you could say 7 hours after the store opened, okay? And there it is in context. Okay, so 1 point for the value on the AP exam, and then 1 point for your interpretation in context. Not too bad. C, is the number of pounds of bananas on display, is it increasing or is it decreasing? Well, think about this. I have a function a of t, and I want to know, is the amount of bananas increasing or decreasing? How do I figure that out? Well, you just look at a prime and you determine, is a prime of t greater than 0 or is a prime of t less than 0? And that will tell you if it's increasing or decreasing. So over here you can see we've already defined this. This is a prime of 5, which is equal to g of 5 minus f of 5. Okay, so I'm going to go ahead, I'm going to compare this. I'm going to compare this in my calculator. So let's enter f of 5 minus g of 5. Okay, are the bananas, are they increasing or decreasing? Are the number of pounds increasing or decreasing? Well, I'm considering the rate in and the rate out. I go ahead and hit enter, and let me move myself, and we get 2.263. 2.26, and actually I flipped this. This should be g of 5 minus f of 5. Right? Because the amount being removed is being taken away. Okay, so we have a negative amount, negative 2.263. This is negative 2.263. Okay, and that's a negative number. This is clearly less than 0. So we can say the number of pounds is decreasing because a couple of ways you could do this. You could say g of 5 minus f of 5 is less than 0. You could say that f of 5 is greater than g of 5, but that would be a couple of ways that you could go ahead and answer this. Okay, D, how many total pounds of bananas are on the display table at time t equals 8? So we want the total pounds of bananas. This is just a of t, okay? And specifically, I want it at a of 8. So you've already put in the legwork. You've already defined this in your calculator. So right away, I'm going to go ahead and say, okay, a of 8. And there you have it, 23.347. 23, this is equal to 23.347. And there's your answer. Now, make sure that you have clearly defined what a of t is. The reader needs to see that you have defined a of t. So you better have this on your paper somewhere. A of t equals 50 minus the integral of f of x dx evaluated from 0 to t plus the integral from 3 to t of g of x dx. Okay, they're not as picky with the variables in here if they aren't different than your limits, but they should be. At least your calculator is very picky on that. Okay, so that is something to consider. Make sure you write your function. If you have it somewhere on your FRQ, then you can write this down, and your reader will know, hey, they went ahead and plugged it in. They use your calculator to calculate that. Okay, you get 2 points for your integrals, having your integrals here, and then you get 1 point for your answer. Okay, so there's an example of rate in, rate out. Let's go ahead and let's look at a fresh example. So here is example number 2. They say a large tank contains 40 gallons of water at time t equals 0. There's your initial amount. During the time interval 0 to 2 hours, the water is being poured into the tank at a rate of Wt. So here's in, this is initial. During the same time interval, water is leaking from a small hole that's being fixed. The rate at which the water leaks out is given by L of t. Okay, here is out. All right, so what I'm going to do right away on my paper is I'm going to say, okay, what's the total amount of water? I want the amount of water in the tank, A of t. Well, I'm starting out with 40, okay? And in this case, I have water being poured in, that's Wt. So I'm going to integrate the rate of water being added, that's the integral of Wt, from 0 to t. And actually, I want this to be W of x dx, change those up. And I'm going to subtract the integral from 0 to t L of x dx. Okay, so there is my amount of water in the tank. In, out, plus the initial. So I'm going to go ahead and I'm going to use my calculator and I'm going to define these. So I'm going to say, okay, menu, actions, define. Quickly, let's define W of x. That is equal to 0.6. Control, I have to move myself again. Control, oh no. I don't want natural log, I just want e. E to the power of x squared minus 1. There we go. Got it. Done. Okay, I'm also going to go ahead and define L of x, which is equal to 6 cosine 0.7 x. Okay, done. And then last but not least, I'm going to go ahead and define now A of x, which is equal to 40 plus the integral from 0 to t, oh no, 0 to x, of W of t dt minus the integral from 0 to x of L of x dx. Enter. Done. Okay, so I have my rate in, my rate out, and then my total amount already defined. So let's go ahead. Let's check out this problem. Should be pretty straightforward. Okay, how much water has been poured into the tank after 2 hours? They want the total amount of water. So that's the integral from 0 to 2 of my water going in. They want the total amount going in. Now, why am I not adding the 40? Well, they don't want to know how much, right? That would be A of t. They just want to know how much is being poured in. So I'm going to go ahead and go to my calculator, and I'm going to integrate 0 to 2 of my function W of x dx. Boom. 3.362. 3.362. Okay, and this is gallons. They don't really call units. You wouldn't be penalized if you don't have units, but that's how much water. 3.362 gallons of water over the interval 0 to 2. B. Find the time t on 0 to 2 hours when the amount of water in the tank is at a minimum. Justify your answer. These questions are meaty. They have a lot of points, minimums, maximums. Now, what you need to remember is this is essentially a global minimum and maximum. How do I know if I have an absolute max or an absolute min? Well, what you need to do if I want the amount of water in the tank, A of t, what I need to do is I need to take the derivative and set it equal to 0. This is going to give me a critical value, and then what I want to do is I want to evaluate that critical value, whatever that critical number is. I'll insert it here, as well as the endpoints, 0 to 2. And I'm going to see, okay, which one of these is a minimum, which is a maximum, and then that will be my answer. So, okay, A prime of t. What is A prime of t? Well, A prime of t, if I went up here, that was W of t minus L of t, okay? And I'm going to set that equal to 0. W of t minus L of t, okay? So here's A of t. Again, I just took the derivative of this, right? It's just essentially those two functions subtracting. So a couple of ways you can go ahead and do this. One is to just ask your calculator, do some algebra for me. Will you go ahead and solve? Will you solve where W of x is equal to L of x for the variable x? And it says sure. And it intersects at two locations, it looks like here, 1.581. 1.581. Okay, so I can say t equals 1.581, and that is my value. There's my critical value. Another way to find this critical number, where the slope is equal to 0 of that function, the amount of water in the tank, would to be go ahead and add a graph. And we can easily graph W of x and L of x. And I can go menu, analyze, intersection, and then I can intersect these, show the intersection of those values. Okay, so 1.581. All right, so now that we've done that though, here's the easy part. I've done the legwork defining A of x up here. So I need to know, okay, what was the amount of water in the tank? Which of these is a minimum? Is it at 0, 1.581? Is it at 2? So what I'm going to do is I'm going to say, okay, what is A of 0? I hit enter, and it tells us 40. That makes sense. They told us this in the beginning of the problem. They said the initial amount is 40. Okay. All right, now, what is A of, and I want this number. I like to just go up and copy it. Well, actually, I can't copy that one. So I'm going to try to be as, I'm going to use lots of digits. 1.5808255. I'm going to take as much of that as I can. And I don't want lowercase a. I think I defined it as a capital A. Okay, and we get 33.424. 33.424. Okay, and then lastly 2. So A of 2. That's 35.185. 35.185. Okay, so when is the amount at a minimum? So we can say the amount of water is at a minimum at t equals 1.581 hours. And there you go. They say justify. Here is your justification, your table. You can clearly show you evaluated your endpoints and you evaluated your critical value. I would assume that this is 3 points on the exam. Okay, C. C. Is the amount of water in the tank increasing or is it decreasing at time t equals 1? Well, what you want, the amount of water in the tank, that's A of t. Again, I want to take the derivative of that. I want to know what is the slope of the amount of water in the tank at 1, which this is just W of 1 minus L of 1. You're comparing. You're pretty much comparing W of 1 and L of 1. And I've seen the points be awarded different ways. You can use this format, W of 1 minus L of 1. Let's go ahead and calculate those. And we get negative 3.989 equals negative 3.989 is what I said. That's less than 0. So water in the tank, the amount of water, it's negative, it's decreasing. We can say decreasing because W of 1 minus L of 1 is less than 0. I've also seen them compared, right? So the amount of water in the tank is leaving. It's greater. L of 1 is greater than W of 1. So if you use this justification, I've seen that as well. Okay. D. The tank holds up to 300 gallons of water. For t greater than 2, water continues to be poured into the tank at a rate of Wt. However, water leaks out of the tank at a constant rate of 1.02 gallons per hour. Set up, but do not evaluate, an equation involving one or more integrals that could be used to find the time W when the tank first becomes full. All right, so first thing, this tank holds up to 300 gallons of water. So when they say find an equation where the tank first becomes full, you're going to want to set it equal to 300. So 300 is our tank. Now, if I want to set up an integral, okay, this is for t is greater than 2. So what I want to know is I want to know, okay, what was our initial value at time 2? So our function, notice at time 2, we had 35.185 gallons of water from a previous answer. And they love to do this. They love to recycle answers. So here is our initial value, 35.185. Okay, and what I'm doing to this tank is I am adding water from 2 to W of t, W of t dt. Now, why did I use W up here? Well, they say they want an integral that can be used to find the time W. So W is our time here. And so that's why I put a W there. So I'm going to integrate from 2 to W. I'm adding this water, okay, at time W. That's when we'll equal 300. And though we are subtracting, I'm losing water at a rate of 1.02 gallons per hour. Now, a couple of ways you could write this. You can write this also with an integral from 2 to W, and then this would be dt. Or I've also seen this as negative 1.02 W. Okay, and I mean that's just what it is if you integrate this. Okay, so so there you go. There is your integral. It requires some critical thinking, right? It's kind of like rewriting that A of t. When is the amount? What is the amount of water? Well, here, when is the amount of water going to be equal to 300? We're starting with our initial value, our rate in minus our rate out. Okay, hopefully you learned how to solve a rate in, rate out problem on an FRQ. I'll have a part 2 where I cover another example. But practice these. This is how you master these questions. Catch you in the next video. Peace.